All right, everyone. So the notes for 7.3 start off with a lot of writing, but try not to get overwhelmed by that because I'm going to help explain to you some of what these definitions mean. Okay. 7.3 is all about lines that intersect and the angles that get formed when lines intersect. So look at the first two pictures here and here. See how they both look like they make an X? That's what some of these are going to look like. Vertical angles are defined as being each pair of opposite angles made by two intersecting lines. And then down here it says vertical angles are congruent or equal in size. We already know that two angles that make a straight line always have to add up to be equal 180 degrees. So if this angle is 120, that would mean that this angle would be 60 because they make a straight line. And if this angle is 120, then this angle would have to be 60 because these two angles make a straight line. But this angle down here that we don't have labeled yet would also have to be 120 because these make a straight line and these make a straight line. So what happens is the angles that are across from each other when two lines intersect to form an X, those angles are congruent to each other. So look at the example here. These two angles here and here are called vertical angles because they're across from each other on an X, and vertical angles are always congruent. So to solve for X, I can set 3x minus 40 equal to 2x minus 10, and then I can solve for X from there. See how that's different than on this one. On this one, the two angles aren't across from each other, they're next to each other. And so we remember from previously, that means that these two angles form a linear pair. They make a straight line, which means they're supplementary, and supplementary means that they add up to 180 degrees. So to solve for X on this one, I wouldn't set these two angles equal to each other. I would say that the first one plus the second one has to equal 180, and then I would solve that equation to figure out what X was equal to. So it matters if they're across from each other or if they're next to each other. When you have two lines that are often parallel with each other, I don't think we've done this before, the markings for parallel can look like this. They can look like kind of like a play button. The markings for parallel could also look like just little arrows that are drawn on the lines. And there could be one of them or there could be two of them. When you have two lines that are parallel and then you have a line that comes across those parallel lines and intersects both or all of them, that other line that goes the other way is called a transversal. If there's two lines that are parallel, it makes 8 angles. So right here the angles are numbered 1, 2, 3, 4, 5, 6, 7, 8. That's not how big they are, that's just telling you which angle is which. There are 4 different kinds of pairs of angles that gets formed. So corresponding angles, same side interior, alternate interior, and then alternate exterior. These are the 4 kinds of different angles that get formed. So let me go through and help explain each one to you. Corresponding angles are angles that match up. They're angles that are in the same position. So looking back up at this picture, see how 1 looks like it's on the top left? Down here on the bottom quad of angles, the 5 is on the top left. So angle 1 and angle 5 are called corresponding angles because they're in the same position. Look over here. Angle 2 is top right, and so down here, angle 6 is the one that's on the top right. So angle 2 and angle 6 are corresponding angles. 3 goes with 7, because they're both bottom left, and then 4 would go with 8, because they're both bottom right. Corresponding angles, if the lines are parallel, are always equal to each other. Okay. Same side interior angles are angles that are on the same side of the transversal and inside the two lines. So it says angles 3 and 5. 3 and 5 are both on the left of this transversal, but you see how they're sandwiched inside the two parallel lines? They're not on the outside like 1 and 7 are. They're on the inside. So angle 3 and angle 5 are considered same side interior angles. And then look on the other side of the transversal. The second pair of these ones are angle 4 and angle 6. Again, they're both on the right of the transversal, and then they're inside the lines. They're not outside the parallel lines like 2 and 8 are. So those are called same side interior angles, and those are different because if you look over here, those are the only ones that add up to equal 180 degrees. They're supplementary. They're not equal to each other, so that's an important thing that you want to remember. Alternate interior angles are on opposite sides of the transversal, but they're still inside the two lines. So it says angle 3 and angle 6. Let's see where those ones are. Angle 3 is right here, inside, but it's on the left. And then over here, angle 6 is inside, but it's on the right. So they're on opposite sides of the transversal, but they're inside the two parallel lines. The other pair is angle 4 and angle 5. So 4 is on the right, 5 is on the left, and they're inside the two lines. With alternate interior angles, a lot of people like to remember that they make the letter Z when you trace them. So 3 goes with 6, and then 4 goes with 5. They kind of make the letter Z. Alternate interior angles are also always equal to each other, just like corresponding angles are. And then the last kind of angle pair are alternate exterior angles. They're on opposite sides of the transversal, so again, they're on opposite sides of the line, but it says they're outside the two lines. So angle 1 is on the outside, it's on the left, and it's on the outside. And so angle 1 goes with angle 8. So opposite sides of the transversal, but then they're outside the lines, they're not inside the lines. And then same goes with 2 and with 7. Opposite sides of the transversal and outside of the two lines. They're kind of, alternate exterior angles are kind of as far away from each other as you can be. And it says over here that they're the last pair of angles that are also equal to each other. So corresponding, alternate interior, and alternate exterior angles are all equal to each other if the lines are parallel. Same side interior angles are the only ones that are different. They're supplementary when the lines are parallel. They add up to equal 180 degrees. So that was a lot of new vocab all at once. We put question 2 on the notes so that we could slow down a little bit and practice the words. It says match the angle pair with the corresponding definition based off of this picture that's given to us right here. So you can go from the pictures to the words or the words to the pictures. I'll start over here. So angle 4 and angle 6, 4 and 6. I'm not going to circle them because this picture goes for all 4 problems. Do you see how angle 4 and angle 6, let's see. Oh, M and N are the parallel lines, so I'm going to add the marking onto the picture. Angle 4 and angle 6 are both under the transversal, so they're on the same side of this line, and they're inside the parallel lines. So inside and same side, so those are same side interior angles. So I'll put the A right here. Angle 4 and angle 6 are both on the same side of the transversal, and they're inside the parallel lines. So that means, by the way, later if we needed to do something, that these would be supplementary and they would add up to equal 180 degrees. Angle 5 and angle 8 are across from each other. You see how they're on the same crisscross? It's not one from over here and one from over here. Angle 5 and angle 8 are vertical angles, and for the purpose of later, they're equal to each other. Vertical angles are not one of these 4 types that we just talked about. They're the ones that we talked about up above in example 1. Angle 2 and angle 6 are on different pairs, so they're going to be one of the pairs of angles. Let's see. 2 is on the bottom left, 6 is on the bottom left, and so those are corresponding angles. And just for later when it comes to solving, that means they're equal to each other. It's good to practice that. And then the last one is here, but angle 4 and angle 5, let's actually trace this one so that you can practice seeing it make that letter Z. Angle 4 and angle 5, if you trace them, I know it doesn't look like a Z because it's turned sideways, but if you turned it sideways it would look like a Z. They're both inside the parallel lines, but they're on opposite sides of the transversal. So it's not like 4 and 6 was or 3 and 5 was, it's 4 and 5. They're alternate interior angles. And alternate interior angles, when the lines are parallel, are also congruent or equal to one another. On question number 3, these 2 angles are same side interior angles because they're both on the same side of the transversal and they're inside the parallel lines. That means that they equal 180 degrees. They're not congruent to each other. They're not equal to each other. So when you set up the equation to solve for this one, you're going to have to say x plus 75 plus x plus 125 has to be equal to 180 degrees, and then you'll go through and you'll solve the equation for x from there. Once you combine like terms, you'll get 2x plus 200 is equal to 180. You'll minus the 200 from both sides, so 2x is equal to negative 20. And so you'll get x is equal to negative 10. It's actually really uncommon that you'll get a negative number for these answers. This is correct. This one just happens to work out to be a negative, but usually when you're solving these, you should expect to get positive numbers. Question number 6. These 2 angles, if you want to trace them, they are alternate interior angles. They make the letter Z when you trace them. And because they are alternate interior angles, that means that they're equal to each other. So I'm not going to set these up and add them to equal 180 like I did on the previous question. I'm going to set them equal to each other. So let's see, that's going to be 6x plus 42 is equal to 18x minus 12. And then I'll go through and I'll solve for x from there. And then I'll add the 12 to both sides. So let's see, that's going to give me 54 is equal to 12x, and then I'll finish by dividing both sides by 12, which for this one will give you 4.5. So just to reiterate, you can get negatives, you can get fractions as answers for the questions. It's more common that you would get whole numbers, but these are both possible. So question number 4, again, if you want to trace them, they are on opposite sides of the transversal, and they are inside the two parallel lines. So that's how you decide that they're alternate interior angles. Because they are alternate interior angles, it means that they're equal to each other. And so for this one, you'll say 2x is equal to 120, and then you'll divide to solve. So x is equal to 60. In number 7, they are on opposite sides of the transversal, and they are outside the parallel lines. The parallel marking from this picture is missing, so you can add it on. Alternate exterior angles are also always equal to each other. So 70 is equal to x plus 16. And so for this one, I'll get x is equal to 54. On question number 5, this 13x minus 7 is in the top right. The 11x plus 11 is in the top right. And so those are corresponding angles. And corresponding angles are congruent to each other. So when I solve for this one, it's going to be 13x minus 7 is equal to 11x plus 11. And then you'll solve for x. So 2x minus 7 is equal to 11. That gives me 2x is equal to 18. And then I'll divide to finish solving. So I'll get x is equal to 9. It's worth me mentioning before we finish that the only one that we added up to equal 180 were the same side interior angles, and then remember all the other ones on this page all added up to equal, were all equal to each other. Let's see. And then on number 8, let me just double check. Congratulations! You can cross off number 8. Let's just make a note right here that says that you skipped it because there's not one like number 8 in your homework. So you're all done.